Hi, here is a demo on testing the MAX77714 evaluation kit. Over here at the center, we have the main power management IC evaluation kit itself, and the power to it comes from the main 15 volt 2 amp bin supply, and I'm giving it over to the MBAT pins of the evaluation kit. Then there is also an option to take power input to the system on this kit through a supercapacitor or a coin cell, which is an optional, but yeah, for now I'm using the bin supply itself. So next over here, this PMIC essentially has 4 of buck converters and 9 load robot regulators. Uh, in this demo, I'm concentrating at the SD0, which is a buck converter, and I have wired the output of buck converter to the Fluke 1 over multimeter, which is here, and also the Unity multimeter is connected so as to measure the load current. So the another specialty of this kit is it does come with the load Mosfet. So for the channel 1 of buck converter, that is SD0, which we're measuring, it has 4 amp inbuilt Mosfet load. So I'm bypassing the connection going to the load and attaching uh, the multimeter probe into it, so that we can the current would flow through the path of multimeter, and we can essentially get the current value. Then also I have hooked up a Rectifier oscilloscope. This would essentially help us look at the output waveform of the PMIC. Over here we have the MAX77714 core itself, and it consists of LDO and buck converters. Then there's a provision to put a console and super cap to keep the RTC going on, and also perform the internal system operations. Then on the below side there are logic supplies. So these are essentially powered through the USB and used for logic levels, and these take powering from the USB. Then comes the main microcontroller. It's MaxQ2000 MCU communicating with all system peripherals via I2C. So take DACs or IO expanders or the 77714 PMIC, they all are linked together with the I2C. And on the top there are IO expanders. These are essentially used to load the load report regulators. So it would communicate with the microcontroller through I2C, take the commands from the software GUI, and control these Mosfet switches so as to turn on and off the resistive loads which are already on board. The same one, these are for all the 9 load report regulators. And then next comes the DACs. These DACs work in a similar way, like they take inputs from the user and then convert it to analogous or appropriate analog value so as to drive the VGS voltage of the MOSFET. So if we could quickly look up at the 6 amp electronic load. So yeah, from here the input to the DAC comes in, and through the output here it gives out appropriate analog values which will go into the one of the non-inverting input of the op-amp. And for the inverting input, the feedback is taken through the sense resistor of 0.02 ohm, and it's fed into inverting terminal so that it has a sense of what's going around and keeps the loop stable. So by controlling the V gate source voltage, the load can be controlled, and they two are relative to each other. So overall with this we can have full discrete load control. In the GUI there is a slider bar, and using that we can access all the load values from 0 amp to 6 amp, and it can be used to apply for the system. Let's now go over to the bench and fire this thing up. So I'm turning on the bin supply and connecting the USB at the same instant. Yeah, we have the board already powered up, and the voltage is set to 3.6 volt, which is as told in the manual. So let me now quickly jump on to the Evk software, and as soon as the both are done, like the device is connected to the PC through USB, and also when it's supplied to the embed pins via the external bad supply, will get this icon to connect. So in a moment it will show the identification of the kit, and then on we can go to the appropriate LDO and tune as we require. So one benefit of having this GUI is like it opens up possibilities to configure and test the system, although while deploying in the field or while putting it into system and uh, working on a specific application, we definitely won't be tuning, but yeah, this is for testing and evaluation purposes. So yeah, now in the nice drop down given over the left side, I'm going and choosing the buck regulator number 3. So with this kit by default, there are certain voltages configured already, like for this HD3 we have 0.9 volt already preset, and if we look at the camera feed, right, we see this 0.915 voltage. There definitely is some offset, that's unavoidable, and it seems to be phenomenal. Yeah, then going back to the software, let's look at the maximum range. It can go up to 3.7 volt. Okay, let's take 3.3 volt as some not too high, not too low point, and write the PMIC. So there we go, 3.3, and right. So as soon as I do that, it will instantly change the value of the multimeter. After this, let's go and vary it a little bit and see how stable it is. Like now I'll put it to 2.0 volts, and let's see to what value it gets set. There definitely is some offset in the second and third decimal place, but yeah, as of now it's reading 3.311, and I have set to 2, and now it's 2.021. okay, there is some tolerance though, right? Choosing another value at the higher one, 3.4 would be fair, I think. Yep, and click on right. Yeah, in a moment it changes to 3.412. okay, so now let's perform a quick load test, and in this window I have also this unity multimeter hooked up in series with the Mosfet load, and we can essentially get the current reading of how much load is applied to the buck regulator and the dissipation stuff. So let me go to the loads option. Over here there is a load control window, and I'm going to HD3, and in this I'm now enabling the HD3. If we look at the cam view over here, it's all 0 now, and I'm slowly starting to increase the load. So 1 milliamp and more. Let's stop at 250 and see what has happened. Okay, anyways, at 259 we see the multimeter turned up. Yeah, we have 0.23 amps now. Put it to 250 millivolts and see how much it reads. Okay, and load. So after this, yeah, it's around 0.22 amps. Next, coming to a little bit higher value. Okay, let's set it as 1 amp. I'm slowly increasing it, and at this moment let's see what does it read like. Yeah, it's 0.97 amp, and yeah, look at the voltage, it has dropped to 2.46 from 2.6. we had set it to 3.4 volt, and after loading it to an amp, it has dropped to 2.4 volt. That's quite large though. Anyways, let's continue the loading and look what happens at around 1.5 amp.